on data cleaning and manipulation will be handled by Mr. Samuel, who is an AI engineer, a software engineer as well, and in every ramification, a data scientist, right? A full stack data scientist. So you are actually going to be, having the privilege to learn from someone who has mastered the topic. All right. So you'll be learning from someone who is a master himself in the topic. So I will just quickly hand over the session now to Mr. Samuel. I'm very sure he's set for us. So get your notebooks or your IDEs set, because it's going to be a hands-on session, right? So we are all going to be practicing alongside his demonstrations. All right, Mr. Samuel, over to you now.
Thank you so much. Good evening, everybody. It's a privilege as well to be here and to with everybody. So I was hoping we'd have standing. All right. So my name is Sam Ayo, and I'll be leading this session on data cleaning manipulation. So for this session, we'll be having just data cleaning, and in the next session, we'll be having data manipulation. So we'll split it into 2 sessions so that we can adequately focus on this. So let me quickly, I think my screen stopped sharing again. Let me just quickly. Oh, before I go on, please, can you confirm that you can hear me? And please confirm that you can see my screen. I need to be sure that I'm on full screen mode and everybody can see my screen. Okay, let me be sure. I wanted to make sure I was on full screen mode. Okay, so I think we're good. We'll be looking at data cleaning, and then, like I mentioned, the next session we'll now focus on data. I'd like to start by we'll look at it from a funnel view. At it from, when I say funnel view, I mean, so let's in our mind, we're going to create an abstract image of a funnel. Funnel looks like it has a big hollow input and then a very narrow output. So you're going to look at it like that, because long and short, that's how data actually is in the real world. Different shapes and sizes, different style and colors. And then when it comes in, as a data scientist, your key area or your key skill is the ability to turn that data from the whole mess that it is into a very, very lean where it comes out from. Filter, because filter is meant to take out the unwanted. All right, but majority of the time in your data, you want to maintain a bit of craziness in your data. That clean, you also want to leave some speck of craziness. Now, why do I say you need a speck of craziness? Real world, in the real world, when your data goes into production, it is not going to be meeting an absolute clean resemblance of what it was trained on. As much as I want to, we look at it as a child, a 5-year-old child or a 2-year-old child. Have a 2-year-old or a 5-year-old child, you train that child. Okay, you train that child on, let's say, colors: red, green, blue, black, orange. That child will only know as much colors as the limit that you have exposed that child to, nothing less. All right, but when you expand or you put that child in a scenario where they have more colors, then you tell them okay, there are some colors that do not actually that you don't have now, but you get to meet them later. The child has an anticipated a mix of color splash, and then the beast of the color splash, they start seeing something that looks like purple, then their mind is put on curiosity mode. All right, so long and short, as a data scientist, what you find majority of the time in the real world is going to be chunk of dirty, messy, unclean data, and you always have to clean it up. Because majority of the time in industrial practice, every single data that comes your way, nobody's going to clean it for you. You're going to do the major cleaning by yourself. Have fully implemented data strategies and fully implemented data hierarchy. Majority of the time, when data has to come in through the pipeline, it will still need some speck of cleaning. And that's the whole exercise of what we are going to try and achieve today. All right, we're going to take on some filter cleaning exercises and so we put our data in a right position where it will be fit for modeling. But then also you should bear in mind that majority of the time you're not going to be doing any much of modeling. Doing data cleaning, data manipulation, and never even get to model anything out of it. Because here in industrial practice also, you are not going to be modeling all the day of your life. In data science, do not even require you to model anything. All right, they may just require you to just do EDA and stop there. That's all the requirement may be. Some of them may just need you to just clean the data and pass it on. It does not mean that when you meet the data, you have to boost, XGBoost, decision trees on it. You must push logistic regression. So the main skill, anybody can pick up XGBoost documentation and learn how to use it. It is as simple as just typing boost model.predict, model.is, just as simple as that. Anybody can do it. But what anybody cannot just do is take through the statistical skill and take through the analytical skill of carefully preparing the data that will yield accurate and precise prediction. And that is what stands everybody out from each other. If not, I mean, anybody can be a doctor. Anybody can wake up in the morning rather and say, I want to be a doctor. And just say, put me in the nearest hospital. If I observe this doctor within 2 days, I will do what they can do. All right, so let's just go straight in. As we go on to the session, I want you to put in the back of your mind, I will be, as we go on, switching my narrative from between a data scientist to a data engineer, and then also to a software engineer. So why I'm doing this is because as we switch the narrative, to give you more grasp of how you handle Python, how you look through the funnel, and how you anticipate your data into, and then finally how you as a data scientist can adequately prepare your data for future use, whether for warehousing or for prediction or for whatever use case the case may be. All right, so welcome once more. Together, we're going to look at what is data cleaning. We're going to look at some other outlines which will involve some technique in data cleaning. The more expanded outline of this will be in the notebook when we go on with the practical session. But for now, we will stick with flow through this, and then when we go hands-on on the notebook, we'll look deeper, dive deeper, and try our fingers on a few exciting things together. And then we'll look at the results together, and then we'll have something we can take home and practice on. What do we refer to as data cleaning? Majority of the time you find a disparity because people try to say, okay, how do we place, what is the role of data analysis? What is the role of EDA versus the role of data manipulation versus the role of data cleaning in the whole data analytics process? And then the next thing they also try to place together is, how do we structure out a data analytics process? All right, so ML, data science pipe creating for yourself, or data science workflow you are creating for yourself. To be honest with you, you may need to put as a rule of thumb is what comes before what. All right, but what is totally up to you. Now, what do I mean by that? The data science workflow for a particular data set. Library, import your data cleaning, manipulation, EDA, and after the rest is up to you. Actually, how you space those few four out are just what matters. After then, whether you do feature engineering or you do whatever, is now totally up to you. Of the time, naming convention can get very confusing. Most people would say data manipulation, or data wrangling, or data munging. Three of them are actually just the same thing. It's just the same way someone was asking me about class versus label versus target. Are just saying the same thing. People just pick their choice of term, but they are just largely saying the same thing. We refer to data cleaning. You're actually referring to a process of filling missing value, smoothing out noisy data, identifying and removing outliers, and then resolving inconsistency in a data set. Right. So in the case of, I want to take it back so that we can spotlight outliers. But before I go on, I'll pause here, and then I would like to take a bit of engagement from everyone. So it wouldn't be, I don't enjoy a class where I have to stay in the front and then I am one Mr. Lecturer or whatsoever. This way, I'm going to open the floor for some responses, your perspective, your insight on how you have seen a particular term, and then after that, I will go on so that we can have an engaging class because it's much more fruitful from there. So we're going to come back to identifying and removing of outliers. All right. So structurally, so if you want to answer a question, feedback that I respond, you can just go into the chat and just signify. All right. If you signify, then I will call you up so you can mute your mic. That way we can manage the engagement within. So identify and removing outliers. So what, does anyone have any contribution you want to put forward on what you think exactly is outliers? So that's one, what you think is outlier, that's one. Then what two, how necessary do you think outliers should be in a data set? And then the third, end up appearing within a data set. So I want you to put it in the back of your mind that if you do not answer, I'm going to call you up. So I put my eyes on the chat and I wait for a while. If you do not answer, I'm going to spotlight you. So just for recap, what you think is outliers, all right? What you think, you don't really have to give me a data science term. You can just give me something within your perspective. What you think is outlier, how you think outlier creep into a data set, and how necessary you think outlier should be in a data set. Okay, I'll start with Queen. Queen, let me give you the first question. What exactly do you think is an outlier? Queen, can you hear me? Hello? It should not be that it is exactly at this time that people's mic have now stopped working. Road. Okay, fantastic. All right, so I moved the question to Chioma. Chioma, what do you think is an outlier?
I think outliers are like maybe the data points that are outside the scope of what you want to do. Maybe extreme values that are not really necessary. They're not meant to be. They would maybe make your data hard to manage.
Okay, sorry, I need to just put you a bit at the center. So when you say outliers are not extreme values, how do you mean by extreme values? Because I'm trying to conceptualize it. Extreme values.
I'm just saying this based on what I think it is. I'm not really sure.
Of course, yes, of course. We all came to learn.
So,
Even me, I came to learn.
What I think extreme values would be are maybe I don't know, maybe some negative values that aren't meant to be there, or values that are meant to be.
Like some negative energy in our data sets, like negative vibes in data sets.
Yes. Like
I agree. All right, cool. Thank you so much. Okay, so that's what we think data set is. Where I wouldn't say let's standardize that, but I'll say accept that. All right, so how necessary should this be in a data set? Yesterday, let's have yesterday try us to that. You should think it should be in a data. Yetunde, can you hear me? So my question is, how necessary should an outlier be in a data set? Okay, so Queen says an outlier is a data point that differs greatly from other values in a data. Okay, we're not going to accept it, so we're just going to accept it. You know, as scientists, we have to probably prove a concept as a normative. But I seriously have my eyes on Temita.
Hello. You said how necessary can it be in a data set? Well,
Yes.
well, I don't know, but I think it's necessary because, for example, like the videos I've been watching from at times, maybe like I just want to give an example for like scores, and then a student outperforms every other student, then is having a very high score, then definitely, I don't know. So I think outliers are necessary in a data set.
Okay, cool. We accept we don't standardize on proving scientifically. Yeah, you gave us your perspective. So as once again, we accept we don't standardize until proven normative. Okay, so cool. All right. Question
Okay,
is,
thank you.
how does it creep into the data set? Yeah, so I think this time I should expand. I can see 4 more, and I don't know 4 more. And I want to expand it so I can pick. Let me spotlight Temitayo at this point. Temitayo, what do you think? How necessary? Yeah, how necessary is already? Sorry, how does it creep into a data set? It's just your perspective. We're not really putting you on the top spot. It's just your perspective we're looking for.
Well, outliers can creep into data sets in a million and one ways. It could be during the collation. So, for example, in the real estate data, some houses could be a million, and then one of those houses could just be as high as 40 million. So, comparing houses from Lagos mainland, and all of a sudden you jump to houses in Aba and cause that. Some of them could be due to error during invitation. It could be maybe the person intended to write 4,200,000, but instead added a 0 and then made it 42 into like 4 million. Outliers could also be probably during tests. There was a time that the data had 40.2 dash, and then most areas where the person claiming saw dash, he felt it was empty set, so he replaced all the dash with 0 to show null, not knowing that he had simply added 0 to one of the data points. So that could happen a million and one ways. I wouldn't be able to discuss all the ways, but I know there are various ways, and 3 of them are probably during the collection. It could be the way the data structure is in real life. It could be during the imputation, and it could also be during the cleaning process.
Okay, super. Thank you so much. I think that also is a solid answer. We, as usual, we accept it until it's proven and then before we can then say it's innovative. All right, cool. I think we can progress from here. Thank you so much, everyone. We've given amazing responses, and it has well put us on a good pedestal to. If you're just joining in, don't worry, you've not missed much. We are even just kicking off, just taking a bit of exercise. But I should warn you that as you join in, you put it in the back of your mind that questions may rotate and touch you. It's not something to put you on edge. It's just something to make your mind prepared, so that as we go on, it's always great if we prepare our minds over something, and then we can always keep our mic unmuted. All right, so let's go on. Move on so that I can at the same time salvage time. Why do we need to clean data? All right, so good data preparation is key to producing valid and reliable models. Okay, so not just only models per se with algorithms, but models as a stance or a conclusion that can be used as a base point to produce other conclusions. So it makes good sense when we have clean and appropriately data that can be used as a reliance point. As one major key thing why the data science process has that cleaning part of it. So what are some tasks we'll be doing? We'll be looking at filling missing values. We're looking at identifying bias. We'll look at collecting inconsistent data. And then we'll look also at resolving redundancy that can be caused from data integrity. So I'm just going to give a very, very sharp hot tool what these terms is and how they relate to themselves before we jump into. So one key I like to drive my learning is conceptualize before practicalizing. Conceptualize, because you conceptualize, then of course you can actually demonstrate proof of knowledge of what you're doing before you can actually say, okay, I'm just going to Stack Overflow to copy answer, or I'm just going to Geek for Geek to copy something and just paste it, and then voila, it works. It doesn't work. The concept of how each of these things work, then of course you will be able to solve the problem faster and understand the direct approach to solving the problem instead of going on a wild guess. What does it mean to drop missing values in a data set? I know for majority of us, this may be like the elementary ABCD 1 to 3, but let's just walk it through. All right, there's no harm in relearning. Drop missing values in a data set. So this technique involves dropping columns or rows that contain missing values that are not needed in the data set. Now, highlight not needed in the data set, because majority of the time when we're working on data science projects, we end up dropping values that are needed in place of not needed. I'm going to demonstrate this when we go on the practical class, because it can be very, very scary when you drop a row that has critical values. Why? It could cause skewness, also cause bias. It could introduce bias into that data set. All right. And for example, let's say you have a data set of students who have been performing well, grade A to grade F. So missing values in grade, you dropped a grade B column. Now you have values that display from only grade A to grade F. Create a model that can actually predict the time series curve of students who have been learning a particular institution over an X period of time. The moment you drop a missing value, that data set is no longer representative of the actual population you got it from, and hence we provide results that are actually misleading. And if evaluations or decisions are derived from that particular model, it will be erroneous. Expand this to a bigger scale and let's say the Financial Economic Committee of Nigeria, and then the collated data set of the agricultural process of the country in the last 5 to 10 years. And then one data scientist who's on a frenzy to prove that he or she is super, decided to drop some columns because he saw that the data set has like 15,000 columns, and decided to drop some columns and say, majority of these columns are useless. And then after dropping those columns, would not even tell you there's a problem, because after you have already done your visualization, done everything, you just thought to drop off the missing column, data cleaning done and dusted. Prediction from it, and at the end of it all, it turns out that you drop off some key states that displayed some critical values that could have been used to make better decisions for that state and some other states. So it's very important that while we are using drop missing values, you pay more attention to the term not needed in the data set than just dropping columns and dropping values. Okay, so let me quickly go on. Tendency. All right, so when we say measure of central tendency, we're actually referring to the three means: the mean, the median, and the mode. All right, so they are critical statistical measures for use when you're making statistical description, or you're trying to make statistical summary of your data set. All right, and they help a lot when you're trying to understanding how your data set actually relates to itself and to all the variables within the data set. So we'll be using it as also a technique for evaluating how best to clean our data set. All right, so you find out that before you can't just go ahead and replace fill missing values just like that. You can't just fill missing values. You can't just drop missing columns because you feel like they are not necessary, or because you feel like they actually have null cells within themselves. It makes more sense if you pay attention to the dispersion, or if you pay attention to the distribution of that particular data set, so you can actually make informed hypothesis before you go ahead and drop that particular column or go ahead and fill with value. Because once again, while trying to fill particular value or with some other values, you may end up introducing bias into the data set. The data set may still look balanced, all right, but it is now biased. So let me make an example again. You have sample from a particular population, and you have done clustering, and you have said, okay, 50 from Lagos, 50 from Abuja, 50 from Port Harcourt, for example, all right. And then you notice that from Lagos that you had 50, you had some missing values. And instead of you to pay attention to the distribution of Lagos State and Abuja and Port Harcourt to make your summary, you just go ahead and say fill missing values in Lagos State from Port Harcourt, or fill missing values in Lagos State from Abuja. The standard of living in Lagos is different from the other parts of the country. Try to do that. You end up discovering that you have introduced bias into Lagos State, because let's say, for example, things are cheaper in Abuja compared to Lagos. All right, I'm not making it from an informed point of view. I'm just using an example. So nobody should quote me anywhere. If you relocate from Lagos to Abuja because of last standard of living, you're on your own. Now, let's say there is from Lagos to Abuja, all right, and you decide to move data from Abuja and put it into Lagos, all right, to fill missing values. You have introduced bias into Lagos because you have influenced the size of different values. And if that is used to draw out a model, there's obviously going to be errors. That's why it also makes more sense when you pay attention to identity. Okay, so outlier detection technique. So there are actually a few outlier detection techniques. All right, so we can look at outliers as an observation of a data point that lies at an abnormal distance from other values. Okay, so in majority of the time you can just look at it as the odd one out. More than one odd one, maybe like 50 odd ones. Or you can see from the example, we have a group of green apples, and then a particular red apple is in the midst of them. Now, majority of the time, it won't be at the end of the data set. It may spread itself across the data set. All right. outliers can exist at the close to the mean. When I say mean, I don't mean the arithmetic mean, I mean the minimum, all right, close to the minimum of the data sets, of the data points within the data set, and also close to the max of the data points within the data set. All right, so the outliers can spread themselves across your data set, or they can appear within each of the extreme points of your data set. Noticeable because the majority of the time they stand out as extreme values. Majority of the time you may need to drop them, but not all the time. Sometimes it makes more sense, or depending on the business case or the call maybe that your outlier may need to reside within your data set. Take out the outlier. So there are several techniques for doing that. All right, we have the trimming, we have the capping. All right, we have a treat outliers as missing values. Also, there's also discretization for treating outlier. We're going to explore majority of these in practical. So I think just prepare your mind ahead for this. So when we look at the trimming, all right, so that's the most common detection technique, removal technique for outlier, where you use interquartile range and then you just eliminate all the outliers at one blow within your data set. It is the fastest, but it is the riskiest. The fastest style to dealing with outlier within your data set, but it is also the riskiest way to deal with outliers. How's it the riskiest way? You may end up losing values critically. You may have a data set of 500 rows, and you have a lot of outlier, and when you treat it with the trimming method, you have only just 200 rows remaining. Almost half of the data set gone. Trust me, you don't want to be in that shoe, especially if you manually collected each of your data set. It is going to be crazy, all right? So while the other one, we have the capping, right? So the capping technique includes where you create a minimum, you make a minimum. You can define your minimum as you want. You may define as your minimum, 90% as your maximum. Any value that falls within 90% and upward 10% and downward that will be treated as outlier, and they will upward off. All right, so that's capping. All right, and then we have discretization, and then we have where you treat outliers as missing value. So from this point, I'm going to pause, and I'm going to take your question before we go into the practical section of the of today's meeting. So do you have any question? I'm going to stop sharing here, and I'm going to share again my book straight ahead. Does anybody have any question?
Yes, may I ask, what is the difference between trimming and removing outliers, treating outliers as missing values? So what is the difference?
And hi. Treat when you take the trim, all right, trimming will take off the outliers altogether, all right. While when you treat outliers as missing values, you can either replace them with a different technique. Maybe replace them with the mean, or the mean of you can either replace them with the mode. That's when you missing values. While if you trim them, you're dropping them off the data set altogether. That's why I said trimming, yeah, is the fastest, but it's the trickiest and the riskiest. Question?
Okay, yes, it does. Thanks.
You're welcome. Any question before we move on?
Yes, I'm sorry. My question is it possible to identify outliers from a domain perspective?
When you say domain perspective, how do you mean by that? Do you mean from the SQL query or direct from the database?
Okay, so I got the one.
Let's say, for example, you're looking at the data and something like age 0 January 2020. Or something like that, that you know not to be like that.
I can understand what you're saying now. So when you say domain perspective, you're referring to as data understanding.
Yes, sir.
Okay. Yes, of course. Yes, you can identify it from there. I would always preach that before you even pick up a data set and try to ensure you read the data set. I'm not expecting you to read the 5,000 row data sets. All right. You can read the first 20 row, read the first 10 rows so that you understand what is the requirement from that particular data set before you make any imports into any notebook and do whatever you want with the data set. So it makes more sense if you read the data set from the data set. So of course, yes, you can make inferences, you can make your own personal hypothesis, all right, from the data set before you go ahead and trim or cap whatever you want with the data set. So it makes more sense, actually. It makes more sense. Then you have age, and then you look through the first column, the first 10 rows, first 20 rows, and then you find an age that says age 0. Right? There's nobody that is born age 0, even if they are going to pick up data sets of children, except, okay, we could use an exception and say, let's say we are making a data set for children who are born in the first of their life. We are trying to spot a disease, all right? And we are trying to make an inference based on that. Then we could say we have age 0, but then that would also come from the data understanding itself. Would help the data scientists know that, okay, age 0 in this data set does not mean that nobody can be age 0. It just simply means that based on the trying to solve with this data set, age 0 is not an outlier. Instead, age 0 is part of the data set because we are trying to calculate children within the age of within the first 6 months of their life, or within the first 1 year of their life, or first years of their life to spot the disease. All right. So yes, you can detect outlier from the understanding, but that largely is upon your ability to first and good data understanding from the data before you start an inference. I hope that answered your question. All right.
Yes.
Can I add something? Okay. Mr. Temitayo, for that question, and thank you, Mr. Samuel, for answering that. So just to reinforce this so that possibly others can take notes, right? The first step to any data project is your data understanding. Samuel has mentioned. So that's very fundamental to whatever you're doing in the data workflow, right? And so when you're dealing with domain-specific projects, just like Mr. Temitayo posed the question, for specific domains, it could be finance, it could be health, it could be real estate, it could be e-commerce, right? In your data understanding phase, your responsibility is to ensure that in all your data quality checks, you see that it's conformity to the domain best practices, which means what is the accepted standard in the finance domain you're working in, or the accepted standard in e-commerce. So when you're checking, the statistical distribution of your data, and you see certain kinds of numbers, you already know which ones fall out of range from what is accepted in that domain, right? You already know. Let's say you are working with healthcare data, and you are looking at maybe blood pressure of patients. You know the range, right? I don't even know. Honestly, I don't have those numbers in my head. But you see, I mean, you know that there's a specific range that we identify as low blood pressure, and then there's the kind of range you identify as high blood pressure, right? And so we have those extremes. The moment you find a number that falls extremely below the low blood pressure range, right, your understanding of the healthcare domain would help you immediately recognize that this must be an outlier. Then you run other checks to be certain about, to be sure that that's really an outlier. And then you deal with the outlier according to what works best for that domain, right? Which is why data scientists or data analysts, typically, when we are embarking on data projects, we don't just use data specific knowledge or understanding to approach data, right? There's something we call domain knowledge, and either you pick up knowledge of that industry or you work with people already know a lot about it. I mean, for example, in some large companies that have user base and interact a lot with their markets, with the target markets, right? You normally have interdisciplinary teams where you could have a marketing team, but in that marketing team, you have data analysts, you have data scientists, then you have marketing experts. So when we're analyzing data in such a team, you will not have the data scientists or data analysts handle the end-to-end projects themselves, right? It's going to be collaborative. So you will not have these guys just looking at the data. That's the data guys now looking at the data and just fetching, trying to fetch the insights. They will fetch the insights based on understanding the data questions, which have been framed from the business questions. You see, and it's the marketing experts now that will help these data guys of it. They want to understand the business of it and understand the constraints from the business side, from the marketing side in this case now, so that the data scientists now can use that domain expertise or domain knowledge as a guide to the methodologies in the data operation. See, so that's very important. Your data understanding is critical to the rest of the data workflow, but data understanding is hinged on domain knowledge, right? And if you just walk blindly with your data knowledge and your auxiliary of data science tools and technologies, and just walk blindly into maybe a domain like epidemiology, studying COVID-19 pandemic, I just want to analyze the data. You would do a beautiful analysis, throw in fancy algorithms that would fail, right? That will not answer the questions. Will answer questions and it will seem as if they are elegant. It will seem as though the answers are elegant, but ultimately, you'll be deviating significantly from the ground truth. Why? Because you're entering a domain you don't understand with your data science artillery, approaching it from just a tactical approach, forgetting the strategy that underlies those practical techniques. So that's very important. So in all, when we are looking at all these operations of data, we have to have it at the back of our mind that what forms the framework, the underlying framework for all this is what the domain specifies. Do data operations, we handle them in alignment with business requirements and business processes and domain-specific understanding. I hope that makes sense.
Yeah, thank you so much, Dr. Zion. Thank you so much. I hope that also helps.
I have a question.
Go ahead,
That if one doesn't
Yes, it
have a
does.
domain knowledge, that means the person cannot work on such a project, or the person will work maybe in collaboration with someone who has expertise in that field.
You can go ahead and provide the answer. You can lead the conversation.
Okay, so for that question, if you find yourself in the domain and you don't have knowledge about the domain, right? Actually, all the domain knowledge you need for data science is not so much deep stuff. You just need like insights about the constraints, the best practices, the boundary for what you're going to be working with, right? And so if you don't have this first-hand insights, right? What you do is you would want to work with someone who is an expert, in that domain, majorly to help you work within the scope of the business side of that project, right? So that the data project is not off. Your data project itself technically be correct. It will deviate from the business value that they're trying to drive. So does it make sense?
Sorry, Zion.
Yes, go ahead.
Yeah, so if I get you right, so what do you mean by the domain knowledge is that like the speak of what data set is all about? I don't know if I get you right.
Okay, the domain knowledge, for
Okay.
example, as a data scientist, you could be working in the finance industry. Domain knowledge in that industry is knowledge of finance. You could be working in the medical industry, knowledge about, domain knowledge is basically medical science knowledge, right? And you're working in a real estate scenario, real estate knowledge.
Be broken into two parts. One part will largely focus on just looking at different cleaning technique on this data. And then warning. So let me just import warning. I don't. It doesn't necessarily you do it. I just like to do it because I don't like the drama of pandas sometimes. So you can just warn it if you want. It's not necessary. Okay, so it can be dangerous into my up there, so we can. Okay, so one. So I may not need to, I don't think I need to why I'm important, what data is. I'm sure we have a bit of a grasp of what data is. It's in my directory, so ensure you place your directory as well. It's already been shared in the chat, right? It's just, so I'm just going to import, and I'm just going to visualize 20 rows. Okay, so what I've just done here is simply load my data set from a folder called data, and this is the data set, data underscore practice. It's a CSV file, that's why it's .csv, and this is pandas.read CSV, and I'm putting to a variable called data that we'll be using to roll out the first 20 rows, all right, the first 20 rows from our data set. Now we can see what our data set actually looks like. It has date, day, period, new. So let's go back and check what NWS actually is again. I don't want to pull anything from my head. This is New South Wales electricity price. So like I explained earlier,
this data set is about a data that was collected from Australia, New Zealand, rather the electricity market. All right, so the prices are not fixed and are affected by market demand and supply, and they are set every 5 minutes. All right, so the prices are set every 5 minutes. So electricity transfers to and from neighbor states of Victoria. So the data set is collected from New South Wales. All right, the data set is the electricity they are consuming within that district was transferred. Part of it is transferred in from Victoria. The sense of collecting this data set is to actually make a prediction on the stability of the price, if the price will go up or the price will come down based on a set of variables. And that's why we have these parameters: the date, the day of the week, all right, the period, the measurement of half an hour applied to the district, all right, the price, the current price in South Wales, all right, the demand for electricity in South Wales, then the price of electricity from the neighboring country that is supplying them electricity, and then of course the demand in that district supplying the electricity, the ratio of transfer between New South Wales and Victoria, and then finally the prediction, which is the class. If the price will go up, go down based on these parameters, based on the day of the week. Let's say, for example, people are always at home on weekends. Will the price of electricity go up? All right. Based on all these parameters, that's why it was constructed. So let's flow. All right, so as I go on, it's very important that if you need to ask a question, you can always unmute your mic and just say, "Hi, Ayo, can you provide an answer?" And then I can assure you I will stop and we can go on. So we've printed that. So we'll move into the next phase, which is very critical for our data set, and that will be our data inspection. Data. Now, a data scientist can be likened to a police officer, all right? And that's why data understanding is important. You are almost a police officer, but this time your jurisdiction or your unit is the data unit, all right? You need to have good grasp of what your data is, make good hypothesis on that particular data before making any conclusion whatsoever on that particular data. To make this an header. So the first part was our library import, and then the next part will now be our data inspection. So from this part, we're going to thoroughly inspect our data, and as we inspect our data and we go, we're going to make some hypotheses, some assumptions, and then at the end of our assumption, we can now go proper into our data cleaning. You cannot go into data cleaning without making first some assumption based on your data understanding. All right, you need to make some assumption based on your data understanding, and then you can now start cleaning the data. Else, you're just going to be cleaning your data without any foundational or without any ground truth you have drawn by yourself to guide you through the data cleaning process. What we are going to do is we are going to look at the dimension of our data shape method in pandas. Oh, sorry, there's no parenthesis. All right, so this is our data shape. So we're just using this to check the dimension of the data set. Let's check the dimension. Of course, we know it has 45,312 rows and 9 columns. Why is this important? We are going to come back to this particular dimension check when we need to analyze what our data cleaning has really done to our data set. It is a gain or a huge loss. All right. Now, so the next thing we are going to do is we're just going to break things down a bit. We're going to check the data set information. Right? Let me make this a markdown. And it's going to be based on data set information. So let me just make it. All right. So the first thing we want to look at is the columns in our data set. Okay, so obviously we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 columns. Majority of these columns are an object. But this doesn't really satisfy us. Okay, it doesn't really satisfy us. We need to look into the data set and they are, because it's important we know that before we perform any visualization, tools do not respect objects. Demand columns that are actually just floats or integers. All right. And if you do that, if you don't know that a column is actually an object, you will keep getting error for your visualization and you will not know why. You just keep wondering, but I saw a tutorial where this guy just visualized a data set and showed us the distribution. But why is my own giving me error? You're not supposed to pass a column that is a float or a float or an integer. Is the okay? Someone says can be recorded. I'll need it. Leaving office now. Recorded. The class is being recorded, so you always get the recording. All right. So it's a more elaborate view. Is right. It's a more elaborate view of what data set is. A data set has the date is a float. Day is an integer. All right. Price, New Southwest price, New Southwest demand down to Victoria demand are all floats, and then our transfer is an object, our class is also an object. Cool. Now, beyond just this, we also want to perform another inspection at the info of the data set. We want to look at the info of the data set. So from this now, we can have another steeper insight into how the data set is, all right? And from this, we can see that if you come back up, you realize that we have 45,312 rows, yeah? Back and look at the data set info, you realize that not all of them have values filled as per this row. It starts giving you insight that you have missing values even before you go ahead and check for if .na or .is null or whatever. From your dataset.info, you already start having insights, all right, on values are and how you can best identify them. Now that we have a couple of our variables have missing values, and we have 6 floats, 1 integer, and 2 objects within our data set. All right, fantastic. We're going to do now in our data will be the describe, right? Quite important, we look at the describe. It gives us a statistical summary of what our data set is. Okay, so this is just a big statistical summary of what a data set actually is. All right. That from here we can also detect based on the count if there are same values. We can see the mean, okay, of each column. We can see the standard deviation. We can see the minimum value that is present in each of the column, and we can also see the maximum value. Then we can see the distribution of the quantile range, or the percentile. 5th percentile, the 50th percentile, 75th percentile distribution across our data sets. And then later on, we'll be relying heavily on these values to be able to successfully treat missing values and also perform adequate cleaning on our data set. So far, if you don't have a question, I have a question for everybody. And I'm going to spotlight you to ask you the question. Any questions so far?
I asked if there was a question. That's why you can't hear my voice, Bumi. I'm asking if anybody has a question. Does anybody have a question?
Okay.
Yeah?
No. I'm following.
Okay. So what exactly have you been following?
Okay, so far we've talked about the data set, how to inspect the data sets, how to get deeper information about the data that we want to work on, so that we don't run into issues while we are trying to get information from the data.
All right,
We've
super.
Yeah. I said, so we've done the data info, the description of the data and others. So I think that's where we stopped.
Thank you so much. That's good. That was a fantastic spot on. It shows you're on track. Okay. Question is saying how the right plot. So for example, we're the data inspection phase, all right? So for data inspection phase, we need to look at a few things to be able to successfully say we have inspected our data. And that would include looking at the statistical summary of the data, which is why we used the describe. All right. So at every stage, you need to ask yourself the question, what do I need to do here? All right. As a data scientist, the first thing you should learn is how to question. You need to be able to raise questions. It's part of the scientific process. All right. You need to be able to raise questions, especially for yourself. So when you receive any data and you're trying to inspect the data, you need to raise questions to yourself. What do I want to achieve with this? What can I be able to achieve with this? All right. So for economics, there are some standard economics question: what to produce, how to produce, for whom to produce. All right. While for data science, you can make it for why am I doing this? What's the goal? What statistical inference do I intend to draw from this? And what insight or decision do I intend to render or to present from this my data journey I'm about to embark on with a particular data set? I would actually give you a particular drive. If you look at what we've done so far from data inspection, we've checked out the we are currently on the data information part of data inspection, okay, where we look at the column, then we look at the data type of each of the column, and then we further on look at the overall information of the data set. And after doing that, we then look at a statistical summary of the data sets, because we're going to be needing that later. It's more important. As data scientists, you need statistics, all right? Relative to other data science roles, but as data scientists, you need it as you go, all right? Albeit it's not 100%, but a good ground grasp, okay, of statistics will help you fly on the long run. So you will need that. Learn the crazy statistics, all right? Let's leave the crazy statistics for crazy people. So we ground ourselves in the concept, okay, and make ourselves as industrial as possible with the right concept and terminologies to go. Phase, you need to, it is the question you ask yourself that drives you to provide answers from your data set. All right, because the answers majority of the time would lie within your data set. But you need to ask yourself those questions, okay, before you can then move on. Because I don't want to just clean a data set without first understanding the distribution within that data set. What's the minimum value in the data set? What's the maximum value in the data set? So I don't remove all the minimum value as bad data, and then all my data have a new starting data point, whereas the original starting data point that was specific to the problem was initially there and I've removed it. All right, did I answer your question? Hamza, did I answer your question? Okay, so all right, cool. All right, so let's go on so that we can manage our time. All right, so the next thing we're going to do now is I'm going to be moving a little bit faster so that I don't use more time than I'm allocated for. So the next one we're looking at now is we're going to be checking data values. Next phase we'll be looking at. Okay, so that'll be our 2B. So what we are going to do now is we're going to check within our data sets. Right? Why do we need to check for duplicates? We want to see how unique. Okay, we want to see how unique. So it can help us on the it can help us understand the uniqueness. Let me use that word of the data. Okay, so this is just what did I miss? Data of duplicates. What did I miss? Let me see the error. Data frame has no attribute duplicates. Oh, sorry, duplicated. Yeah, sorry. Yeah. Okay, so there are no duplicate values in our data sets. Okay, so how can we vet this? All right, our data set says there's no duplicate values, but we need to vet this. To vet this, what we're going to do is we're going to check number of unique values to vet this. Okay, so we're going to check number of unique values in our data set to really vet that there are really no. Oh, okay, that's okay. That's okay, Amzat. That's okay. So this is just to check for unique values in our data sets, all right? So that we are sure that the data is truly representative of itself, that there are no duplicates, then of course it should have abundant unique values. Okay, so instead of me to try to put this in the data frame, I think I'll just move on. What we're going to do is we're going to check for null values. I think this is the interesting part people like more, where we need to check for missing values. I'm just going to say data.isNull. But you notice one thing, if you try to do data.isNull, it's going to represent every single value as a Boolean, all right, which is either true or false. And that really doesn't give us enough insight on what we're actually looking for in the data sets, all right? So what we are going to do is check entirely for the data set, entirely around the data set, and see, look through this data set and tell me if there are any null values or if there are any non-null values randomly within the data set. If we do that with the same is null, we can then go ahead and buttress our point by saying that values dot any, so we can get a Boolean that tells us that there are missing values within our data set. So after checking for null, okay, null will represent every single value within your data frame as a Boolean. Then check for a single representation of the data set if there are missing values or there are no missing values within that data set. And that's why we landed here. Okay, that's why we landed here. And then here we find that it's true values, but we don't know how many missing values are within the data set. So that's where we need to now find out really how many values are missing within the data set. And to do that is where we now have to say our data, the same null value we used here. You see this time we're using .any, sorry. Saying is there any missing value, and if there are, sum it up. Okay, sum it up. And here we have a summation of all the missing values within our data sets. So on the date column, no missing value, date column, no missing value, but on period, there are 3 missing value, news price, 42 missing value, demand, 44, and the likes down. Missing values we have within our data set. Now, this is where the work now starts coming in, because now they are missing values. We need to be very, very dynamic in how we decide to treat those missing values. But we may end up making mistakes. So we need to be dynamic on how we intend to treat our missing values, not make mistake on the data set. So what we are going to do is we're going to move to the next phase, which will involve 2C, which will now involve our distribution check on the data sets. So I should have warned you from the beginning that data cleaning is a very, very interesting phase in data science. Very, very uninteresting. I mean, many data scientists really hate this particular thing I'm doing right now. And they just tell themselves, I'd rather die than do this. All right, everybody just wants to take the data set, clean, sweet, and super, and just. But this is the dirty work where you and I are going to roll up our sleeve and get into the poto and mud and clean our feet and get wet and dirty while doing the job. To familiarize with this basic syntax, SQL is recommended. Well, majority of the time, pandas is more like an abridged SQL query. All right, like why I say abridged SQL queries, they share strong correlation because they perform almost similar attributes. But pandas, if you read through the pandas documentation, they will always warn you that do not replace the callout from pandas with SQL because they are not supposed to be the same. Pandas is specifically designed for operating with tabular data. All right, it's designed for operating with tabular data, while SQL is a structured query language for manipulating data and making database control. All right, so you do not want to interrelate them. Yes, they are similar, okay? They are similar, but no, SQL is on a separate domain on its own. It's a different understanding on its own. You cannot place SQL and pandas side by side. You cannot use pandas to prepare for an SQL interview. To prepare for a pandas interview, you have to learn them side by side. Yeah, Bumi, it's a really dirty job. Yep. Very, very tiring. In short, right now, all my body aches from doing this. But we have to do it. It is very, very necessary as data scientists to do the dirty work. Now, the good part is, what I try to tell people is that if you learn the art, it's an art actually, because it's a full-time skill. If you learn the art and skill of data cleaning, you will ace any data science interview. In short, you will be a voice. Once you master the art of data science, data cleaning. Why? Because majority of the time, organizations are struggling to keep up or fix themselves. They're trying to become data-driven. And they cannot become data-driven without collecting data. And they cannot collect data without collecting dirty data. They need to streamline that data to their own use case. All right, they need to bring it to their own operations. Yeah, they need to bring it to their own operations. All right, and who is going to do that? Of course, it is not going to be the data engineer. He doesn't have that solid grasp of the data cleaning process. His own is to pipeline data, move the data from X to Y, ensure it is there. If possible, perform ETL, and then close for the day, shut down his computer and go home. It's scientist's job to look in the data set and pull out insight from the data set. And you cannot pull out insight from a garbage dump. You need to first collate everything into different before you can do that carefully. All right, so I think we can go back to our kitchen. All right, so what we need to do next now is we need to check the distribution of our data set. So what we are going to do is you can either copy the data set, move the data set. Do I have? Okay, All right. Cool, Amzat. Okay, so can do this. You can either move the data set or you can copy it. So what we are going to do is, did I say move? Sorry, you can either duplicate it into another variable. It's not really duplication per se, all right? But we can either transfer the variable name or of it, all right? So depending on your preference, they all have their different cones. But I'm not going to copy, all right? I'm just going to I want to make an historical visualization, excuse me, of the data set. So I'm just going to move it into a variable called hist_data. Hist_data. And move on from there. So what I just did here is to transfer the data sets into a new variable name. Nothing fancy, all right? Nothing fancy. So like I mentioned, if you have any question, if you're stuck, you need to slow down and then catch up, all right? It's no biggie. I will slow down and I will catch up, all right? I just want to see what I did to be sure that it was successful. Next now is we want to visualize our data. All right, histograms are cool because distinct ordering, all right, and they give us a which is cool for a snapshot of, to give a snapshot as an insight into exactly what you're doing. All right, now, but we cannot do this on a, let me just make the error so we can see it for ourselves. What I said earlier. I'm only making a nested because if I use a single one, then I'm going to be pointing to a single column. If I use a double one, then I can point to multiple columns. So we're going to pick all the variables from here directly. It's just a shortcut. Listen. All right, I'm just making a shortcut. So the essence of doing this so that I don't have to type one after the other, each of them. The only thing I will just have to do is to just so it's much more faster. This data cleaning alone is already demanding that I go for a massage. No problem. All right, cool. So what I've just simply done is to in the data set that I want visualized as an histogram, I have spotlighted all of them within the data frame. All right, so I specified them with the data frame, and then I am now going to the hist method. All right, so the hist method is going to create an histogram for me. Okay, now within the hist method, I'm going to define the size I want it to. So I'm just going to define that I want it as 12 by 12, 18 by 12 rather. I can just visualize. Okay, so we have our visualization set up for each of our variables, except for one. It's all visualized except for one particular variable. Let me reduce it so you can see what I mean.
Now, can you go back? Can you scroll to the left? What did you set as your fixed size value?
Okay, so I set. Let me see. How can I get this guy to just make away from me? Hold on. Let me make this bigger so it can make away.
I think you set it for 18 by 12.
Yes, 18 by 12, but I want to make it bigger for you so you can see. I think it's clearer now. Okay, so what I was trying to say is that you see we have how many target column? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1, 2, 3, 4, 5, 6, 7. Naturally, you're supposed to have an error thrown up. Okay, we are not having error thrown up because I have set warning to off. Okay, that's why I said it's not a good thing to do. All right. So because it is an histogram, it is expecting numerical values, right? For column object and transfer is an object type. You may be looking right here as looking at float, but actually it is an object type, and we can confirm that by data inspection. Object. Float values, but actually that the object, which is quite risky if we do not treat it. All right, if we just let it slide during the exercise. Dangerous, so you mention to your data inspection and now gives you a good view of how it's skewed and to what angle is it skewed, how is it distributed. All right, so you understand how you can treat missing values for your data set. That's pretty important. Yeah, that's very, very important for you to pay attention to.
I have a question.
Yes, please go ahead and ask.
Okay, so for the columns that are represented as objects,
yes,
is it ideal for us to change the data type of those objects because we want them to be represented? You know, you said that if you had not put the warning sign, it would have given you an error. So for some of us that might not have to put the warning sign when we want to clean our data, how do we go about those columns that are object type?
So we will need
do
to
we
transform.
Have to change the data type?
Yes.
To make
we have to.
Or something.
Yes, we will need to transform the data type. Right? It's important that your data set bear equal representation in terms of data type. Some models will allow you, train based on object type, categorical data types. Some will tell you that you must transform all the columns into numerical. Of course, we know that largely machines read values as things as numerical values. They are not natural language enabled until the advent of AI and light. So majorly machines read as numerical, right? We as natural beings are equipped with natural language, but they are numerical. So the nature of these algorithms will require that you transform your column type to type in as integer or float, right? Based on how the case may be. But long and short, majority of the time you have to do that. All right, you need to transform it. We'll look at that as we go. Does anybody else have a question? And did I answer your question?
Yeah, you did. Thanks.
Question? I think I need to move fast because the time slot I allocated for everything and a lot of time on. So let's just move real fast. So keep those unnecessaries and just move to. Okay, so let's just look at one more part of one more important part for visualization. Then we can go on. So I'm going to just say, I'm going to look at the correlation across the data set. for correlation. Use that to make hypothesis. Right. So we'll be looking at we're making a correlation based on the seaborne heat map. All right. So what we're going to do is first we're going to create. I think I should maximize this again. We're going to create a correlation. All right, by calling the correlation method. All right, and then the next thing we are going to do is we are going to create a figure. All right, using PyPlot. Visualize it. All right, so this is just going to be our fixed size. Okay, this is just going to be our fixed size, and what we are going to do is we are going to put that into an heat map. Okay, heat map. Yeah. Okay. Then I'm just going to set it to. I think I like this one, not because there's anything special about it, because it's very, very colorful. Okay, and then I'm just going to set annotation to true. And I'm just going to set the axis to the axis I set right here. Okay. Is that a question? Yes, GNU plot. Okay, what's the essence of correlation and why do we check correlation in our data sets? Okay, so I'll answer that. Okay, I will answer that. Okay, so before I answer that, let me just go ahead and set my data plot and then have my PLT, right? And then I will come back to that question. That is what that is. Fixed size. Axis subplot has no attribute fixed size. Okay, so what did I miss? PLT the subplot. Oh, wow. Okay. Yeah. So it's not no preference, but I just like this color thing. So obviously you can set to whatever color you like. This should give you as much as you want. Okay, so let me just go on so that I don't spend too much time. Okay, so before I move on and explain what is the essence of correlation and why do we check correlation in our data sets? It's quite important statistically because it helps you understand the relationship between two or more variables to a particular target variable. All right, so majorly, right, the correlation between two objects is either between 1 and 0 or 1 and -1. All right. So understanding the correlation between a data set can make you understand the impact that particular data set itself, or let's say the impact a particular column has against a particular target variable. All right. So if further can lead you into checking for variance, inflation factor, the likes and the likes and the likes, and all and all and all. But the whole idea of looking for correlation within your data set is to understand the impact of a particular variable relative to other variables. And that's why that's the whole essence of using the seaborne legends right here. Okay, because they help you check the intensity of the heat to mark the correlation between from each variable to another. All right. So if you look at it from linear regression perspective, all right, the assumptions are always that there's homoscedasticity, right, that there's a linear relationship, and also that the observations are actually independent one from another. Okay, while if we are looking at it from a correlation point of view, okay, you want to look at how each of the variables are interrelated to one another, how far is a relationship between itself, the next its nearest neighbor and the target variable. And that's why you can see it from here. Okay, how you can see it from here. So the items that have one have strong correlation with themselves, and that's why you can see period. Of course, it will have strong correlation with period because it is self as a type. But then you can see it has 0.1 correlation with news price, has 0.45 correlation with news demand, has 0.25 correlation with big price. So all these will help shape your understanding of how you're going to treat the data set. So like I mentioned earlier, while you're cleaning on the way, you don't pull out, while you're cleaning on the way, you don't pull out
And where does that take me in my analysis?
Okay, super. So relationship between variables, as I mentioned earlier, all right, where one represents the strength, highest strength or the highest peak of the variable, and then below that represent the weakness or correlation within with each variable to the target variable. Now, if you were looking at it from a linear regression perspective, all right, the assumptions would be that they are independent of each other. So when you have strong correlation between two variables, you know that this problem is likely not a linear regression problem and cannot be solved using linear regression techniques. All right. While if you have a correlation within data set where the relationship is sparse or they are widely apart, where they have very weak relationship with one another, then okay, yeah, I can apply linear regression to this particular problem and try to solve it. Yeah. So the correlation as technique, correlation as a technique in data cleaning helps you largely understand how your data set is related. So you understand the appropriate technique to employ, whether in your cleaning or in your summary, all right? Whether in your summary or your algorithm. I mentioned earlier, if you check the correlation between two or more variables, because it's beyond just this big wide correlation I've done here. You can draw correlation between two or more variables, 3, 4, all right, to check how well they relate to one another. But because it's not the goal of this particular meet, I'm not going to digress into that, so we don't care. Okay, but the whole data at large is to give you inner insight on how your data set relates one variable relates to another. So you understand the impact a particular variable has against that variable. You can understand how best to treat those variables, whether to drop them or to leave them, and the assumption you can make as the impact they will have on your data set overall if they were not there. All right. So that are some of the information you can collect or you can gather from correlation itself.
Each time we need to call data, it remains
I'm just going to fill everything in here. Okay. All right. So and then I'm going to say, oh, I missed data. All right, and then I'm just going to see that. Okay, let me just use it. Okay, just 5 rows. Okay, so this is successful. Now the first step we are going to take is we are going to remove all columns, all rows rather, that contain null values. Okay, so we are going to remove all rows that contain null values. So I'm just going to call it rows with any dropped. So any missing values, just a short word for missing values, right? Then we're going to drop it. All right. We're going to drop it. Okay. So I'm just going to copy this, place it right here. Right? Because I'm going to be reusing this data.fit to perform the clean all through, maintain my data.fit. All right? I maintain it by renaming every variable according to the actions. So what I'm just going to do is document this so it's easier. All right? So we are going to remove all rows with null values. All right, cool. So just straight up, I'm just going to do this. All right, so what have I done? The first thing I did was to create a new variable name and move our data into that variable name. All right, data underscore fit. But what I'm moving is just only the columns. All right. And how do I know the feature columns? We already saw that from our data understanding. Okay, so sorry. Makes sense?
Yes, better.
All right, cool. It was, oh, this is rows. So what I did was to remove all rows with null values, and then I moved the data we prepared here, cleaning. I moved that that data into rows with any dropped, because I want to be able to reuse this particular data that contains only the features throughout this cleaning process. Okay. Now the next was to drop this the drop NA method. The drop NA method allows us to drop every single data. All right, drop every single data within our data sets. All right, it allows us to drop every single data within our data sets as rows. Rows because we did not specify a particular attribute in here. Specify a particular, I think it's parameter. Yeah, we didn't specify a particular parameter in here. Okay, we didn't pass an argument as a parameter in here, and that is the axis. Okay, that is the axis. The axis 0 it is 0 by default. All right. So 0 simplifies rows and 1 simplifies column. So if I say drop.na axis equal to 1, I'm specifying that drop by column. If I don't, I'm specifying drop by. Right. So before I do this, I want to print, see what is actually happening within my data sets. All right, so that I can see what's actually going on. So I want to actually print the number of rows, okay? The number of original rows. All right, now after doing that, I'm going to now print the number of rows with should I say, okay, number of rows after, let me say after, okay, this makes sense. Number of rows after dropping. Okay. So what I'm going to do is I'm going to format this. Okay. I'm going to format this. All right. But before I do that, long typing. Why this is important is so that understand what we are doing, and we can all not get lost in between our dirty work. Okay. So what I'm actually doing is I'm actually making out. Yes, please.
Please, can you increase the size? I'm not seeing anything, please. Thank you.
How far am I going to increase the size?
Okay.
Okay, is it big enough now? I think I'd increase it some more.
Okay, thank you.
I think I'm at approaching maximum for my screen size. If I can increase. Nah,
it's okay now.
Okay. All right. So what I want to do next is, so what I've done is original number of rows. I'm passing it as a formatted string. After dropping the string, and then the number will drop. Okay, cool. So I think what I should just do is, okay, I think it's going to work. I don't want to make things look too elaborate. I want to drive the point. If you are lost, I will explain. I will definitely explain. All right, I will explain. Not to worry. As I go, what's going on with my computer frozen? Can anybody still hear me? Hello?
Yes, I can. Yes, I can.
Okay. My page is becoming unresponsive. Oh my God. Chrome is under serious pressure. My cursor is frozen. Okay, so let me just, I'm so sorry guys. Chill. I think I should just close some tabs so that, let me just close some tabs. So apparently my column is frozen. Oh God. Okay, I think I should just reload this tab so that everything can just restore itself. Somehow it's frozen. So please bear with me, please. Browser has frozen due to of my numerous tabs. So I'm just going to reload everything to come back. Okay. All right, so I take this back. Please just hold on. Let me share my screen again. Okay, so I think I'm back. So I just need to scroll back down to where we were. Okay. Okay, so this is where we were. All right. So I'm passing in strings. So first to be my data.shape, then comma. Now pass my rows. Okay, position 0. Then finally, I'm just going to find the difference between that and shape position 0 minus position 0. Okay, so let me explain.
Your
What did you say?
shape was wrong.
Oh, wow, I didn't notice. Why is this thing freezing now? Please give me a second again. I don't know why this thing is, like my Chrome is under duress. I don't know, maybe it's because I maximize so much. I don't know, I say. Somehow, it's under duress. Type all that in I just typed. So please let me just try and restore my resize and see if that may cure the whole freezing thing, because it's making me reload this page over and over by saying it is becoming unresponsive. So please, I have to start it all over again. Okay. So please, I will maximize again. Okay. Please just let me see what the problem is, because it is saying that data.shape 0 minus 0. Okay. So let me explain what I did here. Let me try and maximize it gently. Okay, so I hope it doesn't shout that it needs to resize again. So what we've done here is, like I mentioned earlier, we assign a new variable named data.fit, and then we dropped all missing rows. All right. Now, to be able to clearly see what we have done, we needed to print out the results. Okay, the results as per the difference in value, what it was before, what it actually is now. But we need to print it as a comprehensive statement. So we don't just only print out numbers for people to see, they can make sense of what it is. So that's where we have original number of rows. It will, this will display. Okay, so please, I think I have to maintain, Chrome will keep forcing me to restart this cell, this tab rather. I just hope that it doesn't become a problem. It's forcing me. Okay, I think this is better. Let me pull it out from the entire tabs as a separate tab, and let's see the difference. I am so sorry, please. It is just forcing me somehow to. So this is a separate tab now. I hope it doesn't freeze again. So this will show us the original row. All right, this will show us the row after dropping, and this will show, this is a break line, so it takes to the next line and then shows us the difference between second row. Fortunately, it is all gone again. I have to type it. This is, I think this is a deliberate punishment from pandas to me. Enjoy data cleaning. Minus. Okay, just want to quickly run this so it saves. What did I miss? Keyword error 0. The shape minus. Oh, okay. I think this is what she was trying to raise for me the last time. What did I miss again? Keyword error 0. Data.shape position 0 minus rows. The drop any position 0. What did I miss? Data.shape 0 rows 0. Please bear with me. I think I made a particular error. I'm trying to sort it out and find it. Data.shape keyboard.shape 0, comma .shape minus rows. What did I make this error? Let me this error. Excuse me. Let me find the error. Okay. This is serious debugging right now. Where? Oh, I found it. Mistake here too. Yeah. Okay. So we can see clearly that the original shape was, the original rows were 45,300 and 45,312, while the number of rows after dropping became 45,135. So we dropped about 177 number of records by using the drop by row. All right, so this is very dangerous, quite dangerous, because we do not know the nature of the columns or the rows of data we have dropped, and we do not know the amount of bias unless we start making some statistical analysis on that again. So while you're trying to make while we are trying to make to clean our, need to be quite careful of how we do it, because it could be very important part of our data. Let's go on to the next section. I'll just copy everything right here and replace it here, but this time we will be replacing our rows with column rather.
Sorry, I have a question. What what if we look at it in the proportion of the number of rows we dropped as against the number of rows that we still have left? Because we dropped only 177 number of rows out of 312. Can that actually affect the data set as a whole?
Well, you may never know until you visualize it and see the changes that have become of the data. It could. There is a high chance that it could. All right. If the amount of values that were dropped were supposed to be an ample representation of the sample of your data, you have introduced bias by dropping them.
Okay. Okay.
So it could affect, yes, to a particular degree. So that's why I said it may look like the quickest way to clean up your data, drop the rows, but it's also quite dangerous to do that. All right, so let's quickly jump into the next one, which is columns. All right, so this time we'll drop every single missing column, and we specify this by saying axis is equal to 1. By saying axis is equal to 1. And then right here, I'm going to change all my values that were position 0 to position 1. Now, where did I get this position 0 and position 1 from? Back to our data inspection, you find out that where is our data? It gives you a tuple, all right? Position 0 and position 1. So this first, this refers to position 0. This refers to position 1. All right, so I use this to check the number of the rows. I use this to check the number of columns. All right. Okay, so let me go on. So what I'm going to do now is I'm going to run this to see the number of columns that were dropped. All right, so from all indication, we find that we dropped just only one column of our total columns that had missing data. All right, so we dropped only just one column, and we may not really know that.
There are still rows instead of column. The original number of columns.
Okay, so it's just right up. So I'm just going to do that right now. Thank you for spotting that out. Columns and just number of dropped. So we just change this from records to columns. Okay, so I just change this to. All right, so this is also very, very dangerous because you just dropped a variable. If, of course, the variable makes no sense to you. For example, if it's an ID, of course, you can drop ID. But in the context of dropping missing values, it is also dangerous to just drop a column because it has missing values, except if you have understanding of the data set and, of course, you have made your assumptions that it has zero impact on the nature of the data. Then, of course, you can go ahead and drop the column. But aside from that, yeah, it's quite tricky to do that, to just drop missing columns just like that on a data set. It could have high impact on the data quality. I think what have we covered? We have covered we are still at number 1. Wonderful. Wonderful. Everybody, please make your bed. It looks like we are sleeping here today. Okay, so I'll try to be as fast as possible. Exhausted so much time. In the meantime, please, if you have any question, please ask. All right, please ask. I'll be as snappy as possible. So that's
please, can you quickly increase your font size so we can see the coding? We can see the.
Okay. Where is that section again? I keep forgetting that on this on Jupyter. It one time. Where was that again? Remind me to recall that font size play with except I do a quick Google. Can be here either. Can it be here?
Sorry, are you trying to increase the screen or the font size?
Font size.
Okay.
Okay, I think I'll just increase the screen a bit, and then later I can fix that font size thing. But I know I've done it once before. Okay, so what we're doing next, we are filling missing values with 0. Okay, so data 0. Okay, so we're just going to fill missing values with 0. And as usual, we are still using our data.fit. We're going to fill all the missing values with 0. Okay, so I'm just going to do this. When I finish doing that, I'm going to transfer it back into itself. Fill NA with 0. Yeah. Okay, so then what I'm going to do is I'm going to look at, after filling with zeros, I'm going to look at the nature of the data set. Any more missing values? If there are still any more missing values. Right, so let me just quickly identify. Again, what we did was transfer this variable that we have always been using, data frame that contains only the features we have always been using, give it a new variable name, and then right here we decide to fill this with 0, all right, and then we pass that back into our variable name, and then right here we want to see now if there are still missing values after performing this fill with 0. Okay, and yeah, there are no more missing values. Now, this 0 does not imply the 0 right here. This 0 implies that there are no more missing values. So it counts for missing values, sums it up per column. This is an output, and right here it has found that there are no more missing values. All the missing values are 0. All right. I want to scroll back up so we can see the total number of missing values we had initially. 42, 44, a lot of missing values, but after filling with 0, all right, we have no more missing values. Now, this is not a good technique, again, to employ, but as usual, like I said before, it's dependent on your data set you're working on, all right, the requirement for a data set, your understanding you have from data set, the assumption you have drawn for the data set, all right, those will lead to your assumptions of whether to fill with 0, 1, or to fill with whatever. So because you can actually fill them with 1, you can fill them with any value you want. All right, so it's up to you. All right, you can fill it with any, depends on the use case. All right, if you're doing a text-based problem, you can fill them with default values for a text-based problem. So they are no longer null values. So it actually depends on the problem you are trying to solve. All right, how you use the fill.na with values is largely dependent on the problem you are trying to solve. All right, so quickly. Okay, so what have we covered? We've covered rows. Okay, so the next we're going to look at now is we're going to fill with nearest. All right, so that takes us to 3.1, 3.2. I did not even label properly. So let me quickly save that time. 1, 2, 3, 4, 5. 3.1. Okay, so this serves as a guide, just in case. 3.1, so right here. 5. 3.2. Okay. 3.3. Right. 1, 2, 3, 4, 5. 3. Okay. All right. So for this use case now, we are going to fill we are going to perform interpolation. Right. Now we're going to populate the missing columns with the nearest. All right, we're going to perform interpolation. We're going to fill missing columns with the nearest. Now we can either fill with nearest from behind or nearest from ahead. Now what I mean is, let me go back to a description of data set, or let me just do that right here. Let me make particular set, and then just say data dot head. Okay, so you can, if you look right here, you see that we have, this is a missing value, right? Because pandas represent missing value with any n. It says, it doesn't leave it blank, it says any n for that column. All right, so here that we have a missing column, when we interpolate, all right, we either interpolate with backfill, we take this value here, populate it in here, or we interpolate with front fill and fill it here. All right, so we do that based on the assumption that, okay, based on this data set, we can just interpolate, since each of these records are entry at a particular point, we can assume that this is up, 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 then of course, this should as well bear the same value with this one, and it should not deviate mean so much. And of course, this is up, up, up again. This can be filled as backfill for this, and it shouldn't give us so much harm. And the same way, this is down, we can take this as backfill for here, or do this as upfill. All right, so that's how the interpolation work. Or ends with interpolation nearest. So we're going to interpolate. We're going to maintain this, but we're going to call this field underscore nearest. All right, and I'm just going to copy this and replace it with this and this. I'm not going to be using dots fill NA just like that. Instead, I'm going to be using the dots fill NA with nearest. All right, sorry, with method. This is going to help me define how I want to fill. Okay, so I'm going to say B fill. So when I say F fill, that's forward filling. But if I say B fill, that's backward filling. So there's no really rule of thumb. Okay, it's based on how you decide to clean your data. Okay, if you either decide to fill with backfill or front fill, there's no rule of thumb. It's all on you. Okay, so and then I'm going to specify if I want to fill like this by axis or by row, or by row rather. So if I specify my axis to be 1, then of course I'm filling it by row, but I'm using backfill. So I take this value, fill it in here by row. And if I use by 0, that is axis, that's record, I'm filling from here back. All right, so let's quickly do that, and then let's look at how much missing values we have. So it's going to perform the interpolation, and then still have missing values or not. I think it's taking longer than usual. Probably it's just because of my engine. All right, fantastic. Okay, so it did perform the interpolation, but we still have some missing values coming from victim and 1 and victim and 2. Demand and transfer. Now, this could largely be because we could look in and find out why it has missed interpolation for 1 and for the other. And this could largely be because the nearest for Vic demand, the backfill is an NA. So if you have a situation whereby NA is here, and you choose B fill, of course, it's going to run into an error. This is going to be filled, all right, because this one will influence this one, but this one first, because in programming it runs from top bottom, but for this one it's going to be influencing themselves. Each of them are in respect to B field. So this is already
one. While this one is on, so this will read itself as an error automatically. That's why we have one here is field, 25 here. So what we can actually do again is run this again to clean up that mess. Okay, but I think I should just do this interpolation again separately for nearest. Yeah, let me do a front field this time. So you see, it's cleaned up. Okay. All right. So backward field cleaned some up, remaining about two column, and then with forward field, totally cleaned up the data set. All right. So that's for if you use the interpolation. Oh, what have I done? Oh, okay. All right. So I think the next we can do now is we can now work with central tendency. Tendency. What I'm going to do is I wrote down some assumption on the data set when I worked with it. Let me quickly import that in so we can analyze it together. Let me quickly somewhere. Okay, cool. Okay, so super. All right, cool. So now this is 3.4. Yeah, am I correct? Okay, so this is 3.4. We filling missing values with statistical measures of central tendency. And where that would leave us is looking at our data set and making assumptions based on the statistical summary we had before. We assume that we assume that each of these values can be treated using statistical measures. All right. So we're going to start with each of the data set. And of course, you know that you cannot apply this on non-numerical columns. We need to do it on, and to do that, we'll first need to fix that transfer column. Okay, that transfer column that is actually numerical, but then it's registered as an object type. We need to fix it. Okay, so let's start with filling missing values with main. All right, so what I'm going to do is let me treat it at a whole instead of I think I've had a lot of talk to myself. Can anyone still hear me? Am I too fast? Am I too slow? Question or while, and I missed some questions. Okay, so what zero in the bracket meant coffee and cookies. Does anybody have any question? Let you know that this is just part one. So in case you want to go and stretch your leg and drink water, you may want to go and do that and come back. One of the whole thing we're doing. We still have part two. So, so if we have been on this for as much as we are, we have just not even concluded what we are. So, any question? If there are no questions, you trust me, I will call you and ask you a question, and I will put you on the spot. If you have any question, I will definitely have a question for you. And I'm going to ask you to analyze our data. Okay, so we had, so I've actually listed 6 assumptions that I raised concerning the data set. I think we can just discuss the assumptions and then see if my hypothesis is viable. It's an open discussion, all right? If my hypothesis is viable, with regards to the data set. And then, of course, you can chip in your input, and it can better inform us on what technique to apply on the data set. One says, since the period variable is the time of the measurement, 1 to 44, 1 to 48 in half-hour interval over 24 hours, we can safely clean the data set by applying value from the most occurring value over the missing values. Longer, what I'm trying to say there is, since there are points over a time series, all right, we can actually say, okay, if we have 24 hours in a day, random data within 24 hours in a day, and then we did that for Monday, we did that for Tuesday, we did that for Wednesday till Friday, missing data, all right, from they are missing data from Tuesday and they are missing data from Thursday. We can as well make assumptions and say, all right, if they are missing data on Tuesday and on Thursday, then through our data, we realize that on Monday, on Wednesday, and on Friday, we collected more data. We collected more data points around 2 p.m. We collected 2 p.m., 2:30, 2:35, 2:40, more data around. And we did the same thing on Thursday, we did the same thing on Friday. We can safely assume and say, we can assume that the sequence, right? We can assume that the sequence is a relative sequence, and the cross applied for Monday, Tuesday, Wednesday, and that the missing data within Tuesday and Wednesday is the same representation from Wednesday and Thursday. So that's the assumption we are making for hypothesis 1. All right, and that is for the period variable. And that will lead us on to the type of cleaning technique we will be applying for period 1. All right, so I want us to just look at it and what you think about that. Is that statistically sound as an assumption to make? Logically sound as an assumption to make? Can that really not introduce bias into our data set and keep our data sets off human error in terms of decision? Likes. All right. So right now the mic is open. Let's have a data discussion. If you don't discuss, I will force you to discuss. I'm sorry, but I will force you to discuss if you don't discuss. Lie to you and just ask you one big question like this that's like a big grammar. All right, Ebube, let's start with you. What do you think? What is your position as a data scientist? Hello, can you hear me? Hello? Hello?
I can hear you.
All right, please go ahead. The mic is yours.
What was the question? Sorry, I was away from. I just said my name now.
So the question is assumption based on assumption. Position. Yeah. What do you think? One for variable. What is your position? Hello? You on now this call, and all these people are not ghost workers. Okay, Hamzat.
Yes.
While Hamzat will be preparing.
Okay, that's like applying the mode, right?
If you say so.
Like using the mode of the system to populate the missing value.
We are on what we are to do. We are asking
The guide.
Hmm.
I don't get.
Okay, look at the assumption we have made for number one.
See how it will
Based
affect
on
the data or
exactly what you think based on this. How do you think it will affect the data? Is this a better approach? Is there a much more better approach based on the data understanding?
it might not be so appropriate.
Why do you say so? Okay, let's call up a support.
I really don't know.
Call up a support. And delay. Okay.
Can we just see how the column looks, the period? Because I can't imagine how it looks. Is it just
Okay, when you say the column, do you refer to right up here?
the period group from the data set?
Or the description? Do you mean the description or the table?
Oh, I mean the numerical column. Yes, this one.
All right, it's all yours.
So your description says that it's in 30 minutes time interval.
Yes.
Okay. So because it's uniformly distributed like that, we prefer using the mode. Is that how your reasoning went? I'm trying to understand your point one there.
Are you trying to understand how I arrived at my own conclusion? Or
yes.
Okay, so I arrived at my own conclusion based on the description of the data.
Yes.
Based on how the data was collected on the period variable. Get my own data. That's how I made my own assumption. So let me move to that column so you see what I mean. So period says time of measurement, all right, in 1 to 48, all right, is 1 to 48 in interval, all right. So they collect 1 to 48 points
after every 30
30
minutes. Okay.
A 24-hour clock. So obviously you did it daily.
Yes.
So I made an assumption on that data and said, okay, so if we say at every single day, then we can safely say we can apply the most occurring value over the missing value on the assumption that the random data were collected every single day, and the random data, all right, will represent themselves the same for every 24 hours. So we cannot have anything beyond values that will ever be collected. So we cannot have more than 2 3 p.m. We have just 1 3 p.m. Okay, so what I'm going to do,
then I would have to, because I would for me to actually make any conclusions, I would actually need to see the actual distribution of the period variable. Is it more of a normal distribution, maybe from the histogram? Yes.
So this is distribution of it.
Okay, so it's not very normal. Okay, because I was going to say that if it was approximately or a normally distributed, then I would go for a mean. But since it looks different, then yeah, I guess the most occurring value, i.e. a mode, would be best to fill in the missing values.
All right. So a lot of all these kind of discussions are what you would normally have in a data team. Because normally you would not likely be the only data scientist in a team. So this kind of discussion is what you normally have within the team, because normally you need to understand what each variable are and make the right decision so you don't misfeel and wrong analysis. All right, especially when you do the EDA section of the data set. All right, so it is 7:55. We are going to pause here for today's learning, and we continue again. All right, for the second section, which will be the part 2 of it. All right, so we will continue with filling missing values with statistical measures of central tendency, and see where it takes us. All right, so thank you, everyone. I think at this point, I will return the control back to Dr. Zion. And same time, please, 5 p.m. Return the control back to Dr. Zion. And
can you hear me? Okay. So that was just a very great one. I hope you guys enjoyed yourselves. The data cleaning is very laborious and tiring, but sometimes if you're doing this, you can actually derive some pleasure in it. So let me just know in the comments, how was it? Did you enjoy yourselves, or was it tiring? So I have just a few key announcements for us before we call it a night. So the part 2 of the session is going to hold on Wednesday, that's tomorrow, at 5 p.m. So Mr. Samuel will continue this topic. Then on Friday again, we'll be visiting exploratory data analysis and data visualization. All right, so we have sent out the details to you guys so that you can join the session. So you guys will be participating in that as well. And of course, we still have a series coming up this weekend. We'll send out information about that. It's not yet exact details are not out yet. So once that is set, we're going to send out those details to you, and you'll be able to make out time to join the sessions. Now, for those of you that are joining us for the first time, that are attending our sessions for the first time, we are having a cohort starting this February. All right, so for those of you interested in data science or data analytics, we have 2 tracks. We have the data science track, and we have the business analyst track. So you guys will be sending information to you on those tracks. Let me just quickly send the link so that you guys can go through them. So we have these tracks coming up. They are comprehensive 4-month bootcamps to get you into the data science field. And so the training starts next week, Saturday, all right, but we're actually kicking off this Saturday, this weekend, with onboarding. Then from next week, the training starts fully, all right? So get ready. I'm sure you guys have enjoyed this session, and it's only the tip of the iceberg, right? We have a suite of, an excellent dose of topics that we have in those sessions. We cover practically as many sites as you need to know to get started in your data science career or in your business analyst career. So both the business side, we teach you some of the business fundamentals that you need to know, right? And then we also teach you the data operations, how to handle data, how to reason about data, how to make careful assumptions about data, how to model probability distributions, all right? How to build machine learning solutions, and so on and so forth, right? For those in business analytics, you've learned how to visualize data, how to use visualization tools, how to work with SQL, even the data science tracks to work with SQL, right? So you'll be learning a number of tools and technologies for data science. But beyond that, you'll be learning the intuition of data science and the intuition of analytics. So it's not just the tools we are teaching you, we're also going to be teaching the intuition. You will learn how to reason about data, right? And you will learn how to align data approaches to business processes, which means we'll be teaching you, a couple of key details. I won't dive deep into so much of business because, of course, if we have to do that, that will be a lot of months we'd have to take to achieve that. But we'll just teach you a few business thinking when working with data for you to know that it's a lot more about the value that can be the impact in terms of quantifiable value that can be accomplished on the business than it is about the process. So it's more of the product, more of the end, and the process and the tools and technologies are only the means to that end, to support that end. So you'll be learning about all these things. Go through that link, find out more information about them. Take a look at the modules that we have in each of the tracks that you're interested in, and then also begin your enrollments, right? So the training starts with as low as 20,000 naira. The full tracks are actually 60,000 naira, but you can pay by installments, right? So we have installmental payment options, so you can start with as low as 20,000 naira, and then you begin your journey, right? And we also have wonderful instructors and literally walk you through the whole process and help you get to a point where you can stand, you can stand confidently with your skills and break into the space, into the data science space. And then once you are done with the learning process, it's now a matter of building mastery by practice, by continuous practice, by working on projects, by implementing all that you have learned, and now working on the whole thing yourself or on the job and growing from there. So that's pretty much what I have for us tonight. So tomorrow, same time, data cleaning and manipulation, the second part. We're having that still by Mr. Samuel. Then on Friday, data analysis on Friday. And then any updates on machine learning will be sending to you by email so that you can also attend those sessions. So that will be all for now. Is there any questions? Are there any questions before we end the session? Do you have any questions?
Is that just to leave meeting this place?
Sorry, is that the question?
I don't think that's a question. I think
okay. If you have questions, please throw your questions. Because I can see a number of new faces in our midst. In fact, there were actually so many of you at the beginning and the first few hours of the class. But those of you that have met now, you are the ones that typically receive prizes for your persistence and patience. All right, so in the absence of questions, we'll be stopping here. So it was a really wonderful session, a really practical session. I enjoyed the class, right? I enjoyed the class, really. So thank you very much, Mr. Samuel, for that. And thank you to every one of you that participated and were also interactive in the session. I don't like quiet classes, and thankfully, Mr. Samuel was able to pull off the whole thing excellently. So stopping here for now. See you guys tomorrow. All right? Have a pleasant night. Enjoy the rest of your evening.
Good night.
Thank you. Good night. Thank you.